In this video, we're going to talk about some of the physical properties of ionic compounds, okay? And so ionic compounds, remember, they're made up of two oppositely charged ions, okay? And so these charged ions will typically will form a crystal lattice structure or a crystal structure in where the ions are compacted to one another. Oftentimes they're held very rigidly in place due to the opposite attractions between the cation and the anion. Okay, and so you will typically find that compounds look very much aligned, much like this here, where we see the sodium and the sodium chloride, and how the sodium ions and the chloride ions are compacted together in a very structural, orderly fashion, right? So this is where this whole idea of crystals come about. So due to its compactness and the strong attraction from one ion to the next, this is the reason why oftentimes ionic compounds have very high melting and boiling points. So here is just an example of a couple of ionic compounds and its melting and boiling points. And so you see here, you have something like cesium bromide. Its melting point is 636 degrees Celsius, and its boiling point is 1300 degrees Celsius. So the temperatures have to really be up there in order to get these guys to go from a solid state to its liquid state, and then boil from its liquid state to its gaseous state. You have magnesium oxide, which is one of the highest, period, where its melting point is 2852 degrees Celsius, and its boiling point is about 3600 degrees Celsius. So it gets pretty you have to get it pretty hot in order for it to boil away. And so that's just due to the fact that the traction between each of these ions are very strong. All right. Because of this, and the ions in of itself, and so this is the reason why ionic compounds, they are very brittle, okay? And why they are brittle, if you see here, like if you apply some type of external force to the ionic compound itself, whether it be, using your hands or smashing against something, what happens is then you shift the ions. Now, if you shift the ions in a very particular way and fashion, then if you have the same charged ions right next to each other, they are going to naturally repel. And by repelling, then at that point, that's when you get the cracks. That's when you get the brittles. That's when you get the breaking points. Simply because the cations cannot stick together. They cannot be next to each other. In the same way, the anions cannot be stuck together. Because they're the same charges, they will naturally repel one another. And that's why cracks are typically formed within ionic compounds. Okay? Now, another really interesting physical property of ionic compounds is that many of them actually dissolve. All right, and so, like, for example, if you take sodium chloride, and I know all of you guys have done at least something in the kitchen, right? You take sodium chloride or you take table salt, and then you'll probably dissolve in water, when you're preparing foods or whatever the case is. And what you notice when you put in the table salt, it will go into the water, and it seems like it disappears, right? It dissolves. Well, actually what takes place is that if you look at this picture here, that the ions are picked apart by water, essentially, right? And the reason why that happens is that you have some of the ionic compounds, the attraction between the water and the individual ions are actually stronger than the attraction between the ions themselves. And so you'll find that the water will go and actually pick apart these ions because, as I said, the attraction is much stronger there. And so thus it looks like the salt has disappeared or it has dissolved. Okay. Now I just want to note this, that the only way that an ionic compound will dissolve if it's the attraction of the water between the ions and the water is stronger than between the ions themselves. All right. And so if the attraction between the ions themselves is much stronger than the attractions between the ion and the water, then that salt is not going to dissolve. All right. And there are quite a few ionic compounds that do not dissolve due to this difference in attractive forces. All right, and so that's just kind of like the big thing about these. All right, so when we're looking at physical properties, ions, one, many of them dissolve. All right, some don't, but many of them do. Okay, they always form these crystalline structures. I'm trying to. There you go. They form these crystalline structures tightly shaped together, very rigid. There's no room for these ions to roam around. All right. But saying that, and also just bringing one more point, I'm thinking about it. When ions actually do dissolve, then that solution actually then conducts electricity. Okay, water in its of itself cannot conduct electricity. If you have some container of pure water, it will not conduct electricity. What allows water to conduct electricity is that there are ions dissolved in it. And so when there's ions dissolved in it, these are electrical particles, all right? And when electrical particles are free to flow in a very specific direction, that's at that point you have current, all right? And so then it will actually conduct electricity. And so this is probably a good reason why that you don't want to be in the pool while there is a thunderstorm or a lightning storm, because pool has electrolytes. It has dissolved ions in there, like such as chloride. Okay, and it will chlorides are ions that could free flow, and if you allow it to flow one particular direction, there you go, you got electricity. All right. And so that's the big thing about that one. Remember, ions are brittle. They break, and they break due to the fact of the repulsions if two of the same type of ions are next to each other. And so that's where we get our cracks from. And then lastly, ionic compounds, they typically have very high melting points. All right. And so that's just important characteristics to know. All right.